Welcome back, everyone, to another episode of Trivial Objections. Once again, I'm your host, Jared, and with me, I've got another returning guest, Daniel. But for this episode, we've got a new person. His name's Trevor, and Trevor, I'm just gonna hand it over. Just tell us a little bit about yourself and what you do, what your relationship is with the rest of us, and what you're interested in.
All right. Well, I've known these guys for 14 years approximately now. Went to high school together and all that jazz.
Would you say you're the smartest person we know?
Probably.
So there you have it, ladies and gentlemen. He is a smart man. But anyway, so just kind of give us a quick background, and then we'll hop right into it.
Well, I like to do a lot of different things, but mostly I read and play video games. Those are my two big hobbies.
All right.
Solid.
Hey, there's nothing wrong with that. So for today, I think we're going to do a part 2 of our space discussion that we were kind of talking about last time. There's been some more recent developments in that field, and I wanted to discuss them with you guys. As you know, Daniel is kind of an expert in the space, and recently, I think this was last week, President Trump, in I don't know if it was calculated or random, but his speech, he said that he wanted to create a 6th branch of the military and call it Space Force.
Space Force!
Space Force. Came as a shock to some of us, but basically, I guess it's going to be an extension of the Air Force? Is that kind of what they're talking about doing?
No, not really.
Okay.
There used to be talk about a Space Corps, and that would have been kind of how the Marines evolved. And it would have been a corps, but now they're talking about a completely separate branch and calling it Space Force. That's kind of the name change. So it'd be separate from the Air Force.
Well, the idea has been around since the Cold War.
Yeah, it's been around forever. Especially like Desert Storm got it really hyped up.
So what would it do, this hypothetical Space Force?
So the best way to kind of give it is like kind of a history lesson. Back when we didn't have an Air Force, it was just kind of part of the Army. There's a lot of disruption. Most people thought the Air Force was mainly there just to give support to the ground troops, and so the Air Force and everyone who's involved in the flying the planes and servicing the planes, especially this guy named General Hap Arnold, had a huge influence on creating the Air Force, and he said that we should be focusing on air power, and if we could control the airs, that's what's going to win the battles, not just thinking of them as another support squadron. And then that became the Air Force, and then that's kind of the same idea with the Space Force. Right now we're kind of used just to supplement a lot of the other forces, whenever we should be focusing more on specific space targets.
All
right. So when you say targets, what do you mean by that? Focusing on colonization, asteroids, satellites, what?
So yeah, we're not NASA, we're not SpaceX. We're focusing on terrestrial-based. It sounds weird to say that, but Earth-based space targets. So we're focusing on maintaining our constellation of communication satellites, GPS satellites, reconnaissance satellites, and whatever else that we put up there. Maintaining our rocket cadre, our ICBMs, our missiles, intercontinental missiles. Whether or not they'll be part of the Space Force is still to be determined. But basically just maintaining our dominance in space, making sure that we have the best satellites up there, because right now we're kind of falling behind. And it used to be we were uncontested. There was a couple other players like Russia and China, but now every other country is getting into the game, and
it's getting cheaper.
It's getting a lot cheaper, and it's getting contested. We call it contested and congested in space, and there's a lot of different things you got to maintain. You got to maintain all of your radars to talk to your satellites. You have to build your satellites. You have to have engineering cadre to construct and come up with the new technology for the satellites we're going to put up there, the rockets that we're going to use to put the satellites up there. Then like
So would you
there's all the
say
jamming and everything else as well.
Sure, yeah. So would you say that it's more policing? Because right now it's like I feel like as like a random lay person that doesn't know much about it, it sounds like very chaotic and very unorganized up there. And so maybe this would be like the police force of of space. I don't know if that's a good analogy or not. Would you agree?
Yeah, go ahead.
It is. I don't know if you ever actually see the graphic that shows all the satellites that we have right now. All the artificial satellites we have. It is really congested, but it is, from what I can tell, stable. I mean, we don't put stuff up that we know is going to hit other things.
Right, yeah, that's exactly right. It's stable and it's organized. There's space policy out there. There's the International Space Treaty. I think that was 1967. But there's rules. You can't just throw a ton of stuff up there. And the Space Force will go into creating more policy and enforcing policy. But you put it into different planes of orbits, and you're not just gonna throw it up there. Not only just because you want to follow the rules, but also because you don't want to lose your multi-million-dollar sometimes investment by accidentally running into something. The Air Force keeps a catalog of every object. I think it's above 10 centimeters that is in space
And
orbiting our planet. Yeah.
Near Earth orbits, yeah.
So, how many of these satellites do you think are? Well, you may know, but just give me an estimate of how many you think are in orbit at this time.
Thousands.
Thousands? Holy shit.
Yeah.
Okay. Gosh, so maybe this Space Force will help organize all of that jazz and give.
Oh, they're already organized, yeah.
Oh yeah, like I said, yeah, it's all
okay.
we can track all of their orbits. We know exactly where everything is. So it's like we know how to put stuff up without having it interfere with anything else. I mean, like Daniel said, it's too big of an investment to make a mistake.
Okay.
Yeah.
So,
and when he said thousands, think like 20,000 or more.
Yeah.
Gosh, and that's only kind of rise, as we keep.
Yeah, we're putting hundreds up there every year.
Yep.
Gosh, so I guess my next question would be, why is this a military endeavor? I feel like, couldn't we just privatize this and have private companies manage space? Or like, why does it have to be part of the military if we're not going to use it for like
Well, it
war?
is largely privatized at this point.
Like
Okay.
just like that's like saying, why have an Air Force whenever we have Delta Airlines? Like our civilian and our privatized companies take care of civilian and private enterprise.
Okay.
And the Space Force would take care of military issues.
Correct.
Okay. Yeah. I guess I'm trying to see the benefit of the Space Force.
So yeah, the benefit is this. So airplanes are in your face. They're obvious and they're powerful, and you can see their effects, and you get a lot of publication. A multi-million-dollar satellite, a lot of times we don't even talk about it, and a lot of times we can't talk about it, but it serves it's a very, very valuable asset. And a lot of times, let's say the Air Force gets $100 of funding, and because we have these big flashy planes that everybody likes, maybe 95 of those dollars goes towards aviation and every other aspect of aviation, air crew and all the other personnel that we have to deal with, and then the remnants get handed over to space. So a lot of it comes down to money.
Okay.
With a dedicated Space Force, you can kind of budget things better. You don't have to rely on the Air Force to give you what you can have mission plans and yearly budgets and decade-long budgets, because what the breakdown of the funding is going to be.
Okay. So it's more of a money battle. So
Yeah.
this will give more investment into space technology, basically.
Yeah, I mean it's largely money, and there's a lot of other aspects too, like because we're the space. Anyone in the Air Force that's involved in the space industry is still part of the Air Force, and so we go through Air Force training, and a lot of the things isn't really necessary for us to do.
Okay,
Yeah.
so some of your tasks would probably be, if hypothetically the Space Force was approved, you would probably move over to that branch, basically.
Oh yeah.
Okay. Huh. So I did a little reading, and there's a proposal that a supposed Space Force could help really ramp up another space race, whether that's, and this article says it'll enhance the privatization of space, but it'll also, start a new space boom, because we're investing more. If the government starts investing more, then they'll have more contracts for private citizens. Is that also a reason that Trump might want to create this new branch?
Well, from what I've read, I've not read a whole lot. The rationale for it was specifically from, I think, Trump, actually, or maybe from his organization, I don't remember, was specifically to defend assets in space that may be threatened by other spacefaring nations. Yeah, that seems like a silly thing for it, but
Yeah.
yeah.
Not really. So for the previous question, Jared, I would say mostly no. That's not really. That's privatization of space is well underway.
Okay.
Commercialization of it actually, and that's not going to be what the Air Force is or the Space Force is concerned with, because that's going to happen regardless of whether this happens or not. The Pentagon and NASA has already decided that, and ULA is kind of coming to, or United Launch Alliance. That's kind of the big boss that used to be the government-controlled space. But as Trevor was saying, and we mentioned earlier, it's our current constellation, our satellites in space, and there's a lot of kind of hidden combat happening constantly.
Like
So
like cyber war.
yeah, like cyber warfare, jamming. We call it electronic warfare as well. Whether you're lasing satellites or jamming them with GPS jammers. I mean, Russia sells a GPS jammer that works for, I think, 25 miles for like $2,000, just like on the market. Anyone can pick these things up, and we are just working on combating these type of technologies. There's things called parasitic satellites, ASATs. Yeah, parasitic satellites are.
That sounds like a
Yeah.
not good
So,
thing.
so just imagine another country sending up a satellite to either, like, let's say they're sending up to one of our reconnaissance satellites. It operates in the shadow. We're not really like aware of it, but it kind of spies on the satellite and hears what the satellite hears. Or maybe it's just in close proximity to the satellite, and it can kind of soak up some of its signals or jam it or do anything else it wants to it. There's ASATs, which is what China sent up and destroyed one of their own satellites.
We did it too, though.
Well, not really.
I thought we replicated it just to show that we could.
We have it, but we didn't explode anything in our orbit because we know how detrimental it was, and like it destroyed a couple other things, and it put an extra 10,000 pieces of debris into, like, half of the debris is caused by the ASAT that China sent up.
That was 2008. We destroyed an American reconnaissance satellite to prove that we could. I thought.
Not that I know of. Maybe.
It
I don't know.
was 07 that China launched a satellite to destroy that, to determine they blew up one of their weather satellites, and 1 year later the United States matched it by destroying an American reconnaissance satellite.
So it sounds like this is just the next step in the human phase of war. So we create a space force, now Russia's got to create a space force, and China's got to create a space force, and eventually we're just going to be fighting in space, and I feel like it's just moving our entire human civilization outward. When some people may argue we need to focus more on the Earth and, combating, global warming and food shortages and stuff like that. Do you guys, what side of the fence are you guys on? Do you think we should move out and explore, or should we try and focus on what Earth has to offer before we try and create space forces and rockets to Mars and stuff like that?
I don't think it's hard to do both. I mean,
Yeah, why can't we do both?
there's
Yeah.
billions of people on this planet, and like a very small part is focusing on space right now. And what's the other 99% of the human race doing? All they have to do is start recycling or not eat junk food as much, not use plastic straws, and the Earth is going to be better. So I think it's a pretty low effort on the rest of the world to do that if we're going to focus on space.
Okay, so you guys are pretty big supporters of, moving past and trying to explore the cosmos.
Absolutely.
Absolutely.
Oh, I would tend to agree. I think that is the future of science. Like, the more we understand about what's out there, that can only be beneficial to, life on Earth. And I think we touched in the last episode about, what it would take to colonize Mars, and that the future of our race is going to be out there, and how the steps we've taken to get there. Tanny, I wanted to also bring up something we touched on at the end of last episode on the James Webb our new telescope, and supposedly it's going to be just 10,000 times better than what we currently can see. And how is that going to benefit us by being able to see? I know you said it's going to, but how is it going to help us, scientifically, and just knowing more about the cosmos?
I think the biggest obvious scientific benefit for it is just kind of seeing the beginning of the universe.
Yeah.
And that's the one that people focus on most. It can see basically to the edge of our visible sight of, how far you can see into the universe.
So right now we can't see the end of the universe, if there is one. But you're saying with this new telescope we could potentially see the end.
Right. Yeah, like with Hubble, you see like some of the first galaxies like right on the edge, and James Webb looks further back into that, all the way to the first stars, and kind of to the edge of what's seeable. Like beyond that is just kind of I don't know if you've ever seen those pictures of what like they call like the cosmic the microwave background is just kind of nothing but like a shock wave from the Big Bang, if you will. And James Webb could basically see anything that we are able to see, as far as the current spectrums that we look at.
It would also allow like direct imaging of like exoplanets and novas and stuff too.
And that's the thing I'm most excited about, is the spectroscopy aspect about it. It's like it's operates in a specific radiation spectrum of infrared that is specially chosen to observe the atmospheres of distant planets.
Okay, so explain that a little bit, because it's a lot of jargon. But so basically, we're like amplifying light, from what I understand, and we're able to see more clearly and closely into these planets and stars and stuff like that.
I wouldn't say amplify. It's kind of like, think of it like an eyeball. The bigger your pupil is, the more light it gathers up.
Right.
And if you look at like how big the mirror is on the James Webb, you can kind of compare it to the Hubble. know what the accurate one is. Like 7 times larger or something like that.
No, it's not that much larger.
6.25 it says here.
Okay,
More collect.
Yeah, go ahead.
So
Sorry.
6.25 times more collecting area. So it just collects a lot more light, and then it focuses, not so much amplified. They redirect it into its viewing sensor. But yeah, so you look at a faraway planet, you point it at that planet, and then you can kind of see how. So whenever light passes through a planet and kind of goes through the atmosphere of a planet, it has a certain signature.
Okay.
And James Webb can detect that signature really well and tell us what type of elements are in that planet's atmosphere.
So it's not really a picture per se, or it is. It's more just light. The way light reacts, basically.
It's going to have the ability to get to view higher redshift objects, which means that, like Danny said, it's going to give us a better clarity. It's got more forms of observation as well as having a larger observation area. So ultimately, it should have significantly more information available.
And it's going to be, it'll take pictures. So like it could take a picture in the infrared. It's just going to look like what it sees isn't going to be what you would see with your naked eye because you see in the visible spectrum. And so like a lot of times people say, oh, that's just fake coloring. Well, it's just what it looks like in the infrared spectrum. But spectroscopy specifically isn't really taking a picture. It's evaluating the signatures.
Okay, so it's not like us like zooming in with, like, say you would be with a camera. You zoom in.
Yeah, you're not like zooming in and looking at the planet saying, oh, look, there's trees and a little monkey flying around or something. No, you're just...
No.
Okay, so we're basically seeing more light refracting off of these planets in infrared, basically.
Right? Yeah, and like Trevor said, it has a lot to do with the Doppler shift and what it's able to see.
Another thing that I just found out, they're planning on putting it in the L2 Lagrange point of the Earth-Sun orbit, which basically, all right, so what that means is it's going to be about 1.5 million kilometers beyond Earth orbit.
So it's like really far out, past the moon.
Yeah. By comparison, that's Hubble is only 550 and the moon is 400,000.
Wow, so it's really far away. So what's the benefit of putting it there?
A couple things. Lagrange points are like solitary points. They're not. They kind of they're unique. So they'll orbit with the Earth, and so basically it will always have a sun, like a sun shield, because the Earth will always be in between the satellite.
Oh, okay, yeah. We kind of talked about this last time with that spinning magnetic ball thing.
Right. Yeah. Like Mars is putting we were talking about putting a giant dynamo to generate a magnetic field in Mars's Lagrange point to block the solar radiation.
Ooh, I hadn't heard that.
Yeah, I hadn't either, and LG was telling me about that. So yeah, you just put, like, I think it'd be in its L1 Lagrange point, and it'd just be a giant man-made dynamo that would generate a magnetic field that would act as a bow shock.
Okay, so putting it in the Earth and Sun's Lagrange points, this
James
Webb thing.
So yeah,
go ahead.
It'd be on the far side of the Earth, like away from the sun.
Oh, away from the sun. Okay, and what benefit would that have? It just means that it's always in our orbit and it's not being affected by anything.
Yeah, it's in our orbit, and there's less like interference from the sun.
Right. It would. Yeah, because otherwise we're going to get too much infrared radiation from the sun. Yeah.
Okay.
Because it has to be kept really cold to be able to work properly.
Yeah, the like temperature differential from the hot side of these things to the cold side is pretty. I think it's like, I don't know, 600 degree shift, something like that.
It's nuts. It's pretty high. Yeah.
Okay, so it's not to see things more clear. Well, I guess it is. It's just to prevent as much sun interference on what it can see, basically.
Right, like if you're looking through a telescope, you're not going to have all your lights on. You're going to do it at night.
Right.
It's a similar concept, except the sun's a lot bigger and more.
Yeah.
Sure. No,
causes more issues.
Yeah, that's like if you pointed your telescope at your light and tried to look at it.
Yeah, try to look at something behind your light.
Yeah,
Mhm.
that's okay. So would we be able to like point it in a certain direction and
Oh,
or
absolutely.
okay,
Yeah,
so we could
wherever you want.
okay. So what we could potentially find out a lot of stuff with this new.
I'm extremely excited.
Oh yeah.
So yeah, it's gonna be really good for theoretical physics, and who knows what type of advances we'll get from
Mhm.
whatever they find out, kind of about the beginning of the universes. Maybe they'll come up with more data about what happens after our universe keeps expanding. Where we're gonna get really cold, really hot. We're gonna have a big rip, but we're gonna find a lot of data about how many Earth-like planets are there out there.
Oh yeah, for sure. I think that's what is most intriguing to me is Earth cannot be the only planet in the universe that has
Well,
this type of
yeah. According to relatively recent research, so from what I understand, nearly every star has planets in the habitable zone.
Oh yeah, that was pretty mind blowing whenever physicists found that
Yeah.
out because they thought they were much rare, and then they're like, oh, I guess
No,
they all have planets,
it's really
and
high
and
percentage.
they all have habitable zones. Yeah,
so that's one criteria.
it makes the Drake equation even stranger.
What's that?
I said it makes the Drake equation even stranger. Or wait, no, sorry, the Fermi paradox.
So for the layman, what's that?
The Fermi paradox?
Yeah.
That's just talking about how much time has gone by since the universe began, how many planets are out there. It takes in it takes in something like the Drake equation, which is an equation that the scientist named Drake
Okay.
developed to kind of develop how likely life is based on the amount of planets in the world and how
Mhm.
long and all that stuff. And it's like, where are all the aliens? Where we should have met someone else by now. The paradox is. Um, there's a lot of detail into it. So basically, it talks about three classes of civilizations: type 1, type 2, and type 3. Type 1 is you harvest all the energy of your planet. Type 2, you harvest all the energy of your sun. Type 3, all the energy of your galaxy. And
Okay.
you basically become a galactic civilization. And it's a paradox because there should have been something. And so since there isn't something, either we're the only ones out there or that there's something called a filter, the Great Filter, and
Okay.
that once all civilizations get to this filter, they die off. And we're wondering if our filter is behind us and everyone else died out and we made it through it, or if we haven't quite hit that filter that killed everyone else. Either way, it's kind of a scary thought.
Huh.
There's a couple really awesome videos on it
Oh.
on YouTube. I definitely recommend. I'll link one in
So I'm
the
just
chat.
picturing. So I'm picturing this like. Have you guys played the game Mass Effect?
Yes.
Okay. So Trevor, in that game, there is a thing called the Reapers, and they come and they just pretty
Yes.
much destroy galaxies and they kill everything. I'm
Well,
just
they don't destroy galaxies.
they just
They
kill them.
reset them.
Right. So that's what I'm picturing with this filter. Like maybe not so like an intelligent
Yeah,
species.
that's there's a lot of different ideas of what the filter would be, and that's definitely one of the prevailing theories.
Yeah. All right. Because Danny doesn't know, and this will probably make a little more sense. The Reapers are they're AI is what essentially they were, and
Mhm.
whoever their creators were, they fell behind the AI kind of thing, and the AI decided that their creators weren't uh, effective, and
Mhm.
that they basically didn't deserve to live because they were lesser life forms, and then decided to just harvest what they could from them and then cleanse. And they've been doing that on a cycle of every 50,000 years or something like that.
Yeah.
Gosh. So that's one theory. Or another theory is we're just alone.
Yeah.
Well, yeah, there's a couple other theories. There's a theory that every time a civilization advanced enough that they just end up killing themselves with nuclear weapons or some
Right.
other
or they
apocalyptic.
or they run out of resources and they just die because they couldn't find a way
Right.
to like
Yeah.
keep spreading.
Yeah, there's hypothetical explanations to the paradox. There's like either we're alone or no one else has risen yet and we're the first.
Which would give us a crazy advantage.
Possibly,
Which would
if we can
probably
destroy
make,
ourselves.
yeah, it might make us the first type 3, and then we just end up living alone anyway because we kill everyone. But
Yeah.
there's a lot of different ways it could go. But there's a cool video I'm linking now.
Okay. Hold on. I may link this when we play this back, but oh man.
Yeah.
Okay. You put that in the
Yeah.
in the podcast one. The Fermi Paradox. Okay, this is gonna be
This guy has a bunch of good stuff.
okay. So, when you guys mentioned that this James Webb could see the beginning of the universe, you're basically it's just gonna find the origin of the light source.
The origin of the light source is literally in any direction you look.
Really? So explain
Yeah.
that just briefly.
So the Big Bang happened at the center point. Like the Big Bang, everything was this one point, and then it expanded.
Mm-hmm.
And so the edge of the universe is expanding in all directions
Right.
all the time.
Okay.
So, and that's the edge. That the beginning and the earliest stuff is at the edge of this expansion.
Mm-hmm.
And so, whatever direction you look, you're looking at the expansion. It's kind of like the best explanation I've heard is like a balloon.
Mm-hmm.
Like if you start blowing up a balloon, you put your finger on one spot, or you like draw a dot on one side on one part of the balloon,
Mm-hmm.
and you blow it up. Every other part of the balloon is getting further away from you, further away from that dot.
Okay, got it.
Yeah.
So light's coming from every direction, basically.
Well, light's going away, but yeah, also coming. Eventually, it's going to expand. So, because it's getting quicker, its expansion, and eventually it'll get to a point where, it is expanding quicker than light is coming back, coming back to us, and so we won't be able to see the edge or even distant galaxies or anything outside of maybe or even our galaxy after a certain point in time.
Because the universe is expanding faster than light is traveling.
Yeah, so like
Wow.
in our distant relatives or distant descendants, they won't know anything exists outside of the Milky Way galaxy, except for what we told them used to exist. Like they'll be looking up at a sky much darker than ours.
Because it's too far away for us to
Yeah.
see.
Wow.
Yeah, because let's say it's so many light years away, and light only goes as fast as light travels, and if it's further than that distance and it's still traveling away,
We'll never be able to get to
Yeah.
it.
yeah, it'll never get to us. It's not that it's expanding faster; it's just that it's expanding fast away, and it's trying to travel back, but it's still going away.
Wow.
It's like walking down an up escalator.
That's insane. So I think it's mind blowing to me when we look at something far off on these telescopes or whatever, we're seeing them if they're 20 million light years away, we're seeing them as they were 20 million years ago, right?
Yes.
So theoretically, a lot can happen within that time. Like we may be looking at a dead planet, but at our frame of reference and time point, it could be a thriving civilization. We just don't know.
Yeah,
Right.
So,
it's pretty.
God,
Everything you see is really in the past, though. You never see or experience much of the world in the present.
that's crazy. That's just so
Yeah.
mind-blowing to me.
Yeah.
Oh my gosh. So, what do you guys think? Do you guys lean towards this filter theory, or like from your experience, where do you guys lie on this?
I don't know, honestly. There's so many different options.
Yeah.
In this.
It's a lot of. I think it's a lot of combinations. So I think that a lot of people probably got hit by natural disasters, whether it's a comet or global warming or ice ages or something. A lot of people probably killed themselves, and a lot of it, like developing intelligent life is a really, really strange path, and not necessarily inevitable. We aren't like the strongest. We humans evolved, our big brains for, we weren't evolving to do physics. We were evolving them to communicate with each other, to work on plans. And
Survive.
yeah,
Survival. That's all life is, though, is survival.
yeah.
So if life is created somewhere else, there's reason to believe that it would do the same thing, try to live, right?
Shoot, I mean, yeah. If think about how long humans have been around for. Not like just a blink of the eye, as far as
Oh, a blip in time.
yeah, just how long the Earth has been around. Now compare them to the dinosaurs. The dinosaurs lived so long that, like the Stegosaurus and the Tyrannosaurus Rex, both lived for millions of years, but neither of them ever saw each other because they were
Right.
separated by time. Like the
Really?
dinosaurs were just on this planet forever, and they didn't have any need to evolve big brains or anything because they were, perfect. They controlled their environment, and if it wasn't for that asteroid that killed them, we wouldn't have intelligent life on this planet, probably not, because we would just have dinosaurs, just like it had been for millions of years.
I mean,
And
didn't the dinosaurs evolve to be smarter and faster and stuff like that? Or no? Is that
Well, what it's all selection pressures. Basically, desirable or beneficial traits are the ones that generally get passed on because those animals live longer and produce more, as
right?
opposed to the ones that develop traits that don't work and they just kind of die off because they don't produce like their offspring. Like for example, the only reason dodos existed is because they're isolated. If they existed
yeah,
on like any mainland continent areas, the animals there would have killed them off long ago.
It's true. So it is not inevitable that every planet with life will have intelligent life like ours, because so
Or
many so many random acts of chance created
yeah,
our
well,
thing.
think about it this way: we've only had radio waves for what 150 years.
yeah.
Like Dan said, that's a blip. If,
That's nothing.
for example, say aliens are using interstellar travel or whatever,
Mhm.
they could be way beyond radio travel, and they're not even trying to pick up radio waves anymore, kind of thing.
Yeah.
Another option is that they're just too alien. For example, they may not resemble us in any way, shape, or form, and therefore to them we don't like we're not significant. We're another just
They like
Yeah.
terrestrial life form.
And then look at the steps of like how we treat our animals.
mm,
Like animals that aren't even that dumb, like octopi and sharks and dolphins or whatever, like we put in zoos or we eat them and we cook them up and put them in soup, or all these things that we don't even think about them, and they're
yeah.
not that much stupider, and
Stupider.
stupider.
Okay. No, it's so
But
true.
if they were just like one, like if they're, first of all, if they're traveling through the galaxy,
Mm.
we are nothing but ants to them.
Oh yeah.
Possibly.
So what would they do? They would just.
It depends if they want to put us in a zoo or eat us, I guess.
I think
It,
that's
I mean,
inevitable.
a a cool thing that was in pop culture, like Star Trek, maybe they have something along the lines
Oh yeah,
of the no interference policy. If this life form isn't advanced enough to contact us and see us, then we shouldn't interfere with them because we'd interfere with their natural development.
right.
I can't remember there's a name for it, and
Yeah, I know what you're talking about.
can't remember what it's called, but
So okay. So basically, if you're intelligent enough to travel the cosmos and you see a small little Earth, you're like, well, let's not touch them. They're young infant babies. Let them, spread their wings and do that. Is that what you're meaning? Or I'm not really
yeah.
sure what you mean there.
Well, for example, all right, say that we could go back in time and go back to like Neanderthals and the other previous versions of humans,
Hmm.
and we give one clan a bunch of assault rifles. That would drastically change their evolutionary process. They wouldn't be human anymore. Like it's because they would evolve completely differently, or they might kill themselves. They might destroy themselves. It's one of those things too.
Yeah. That's what's insane. The fact that we even exist is a happenstance of luck and chance and so many different things. It, it's hard not to be fascinated by that and just
Oh,
you know,
absolutely. That's why it's one of the. It's a very large field of study on how we came to be. Like,
Mhm. Yeah, we've been studying it for a long time, and we don't know. We have no idea.
that's why
Isn't that
like
weird?
that's why I feel like I don't blame or blame us for trying to create things like God or ghosts to explain things because I feel like we need to understand them in some way because I feel like if we try to rationally think about it, we really can't really explain anything. Like the true meaning of anything.
I don't know. We can explain quite a bit with rational thinking.
but rational thinking isn't enough for some people, which I don't blame them for.
Yeah, I mean, some people just accept. It's like, oh yeah, we're just here, we're doing it. But like, some people just want to get to the root of the solution. But really, we don't have one. Maybe this James Webb will be able to see the beginning of the universe in this big giant bang. But like, what are we gonna find out? That it's just random. I don't know. Crazy stuff. Crazy stuff.
Hmm.
Gosh. So, is there anything else that you guys want to discuss about space or telescopes or satellites or Space Force? Because we just got really deep there, and I looked at the clock, and it like 30 minutes just like flew by. So, was there anything else that is you think we should talk about or discuss when it comes to the cosmos?
We could probably go on for days about all of the different
Oh
things.
yeah.
Um, I don't know. I wasn't part of the last discussion, and I haven't watched it yet, so I don't know how much. Have you guys talked about colonizing solar system, or not so
Yes,
much?
We touched on
we
it.
briefly touched on basically how to make Mars habitable. Because right now it's not. Like we'd have to live underground from what because the surface of the planet, a human can't survive for more than a couple minutes, basically because of the solar winds and just the drastic harshness of the surface.
But
So last time we talked about how to make it put it water on the surface or create a magnetic field. I think that we talked about that, but
well, there's
yes.
other options. Mars isn't the only option. One of
Oh,
the moons of Jupiter, I want to say Ganymede, actually has a electromagnetic field on it,
okay.
and that's a theoretical possibility too. I think they also have ice and water. Um, Obviously, it's much further out and would have its own issues with becoming livable.
But isn't that
But
outside of what they call the habitable zone? Like that Jupiter's far.
it is, it is. But you would always have to still have to live in like domes or underground and stuff. But that is an option. Um, it would
Yeah.
actually theoretically take a little less to live there
Well, doesn't
artificially.
well doesn't Mars have water? It's got ice and water underground, right?
Hmm.
It does, it does.
And it's a lot
But
closer
Ganymede's got like an entire ocean under the crust.
under the crust. So it's like crust and then ocean.
The crust is ice.
So the whole
It's
planet's
giant.
covered in ice.
Yeah, and the core. I think the core is a heavy metal of some sort. I don't remember. It's been a while
Yeah.
since I looked.
There's a lot of planets that have a lot more water than even Earth does,
Right, and but
and planets and moons.
well, the key part of Ganymede is that it has a metal core, which allows it to have the electromagnetic field.
We just gotta heat it up,
And
but we can't do that because it's too far away from the sun, man.
well, that's when you take into effect like you could put sun collecting mirrors in orbit. You could use geothermal power to help heat. Just waste energy from having everything running. would help create extra heat. There's all sorts of other things to do that you could do. Terraforming is not the only option for colonization, in my opinion.
So we could just create domes on this giant ice sheet and like drill holes into the ice to get water.
Or
Yeah,
even asteroids.
there's lots of options. I mean,
Hmm.
think about just living on a ship, and then you can just think about the ISS.
Mhm.
You can if you mastered reclamation, like reclamation of your water sources and growing food on ships, you can just kind of orbit wherever you want to orbit.
So we're growing food on the space station?
They're practicing.
Yeah, it's all hydroponic though. It's not natural grown. Like Ganymede is one of the places that we could theoretically have naturally grown if we could collect enough sunlight to get to the plants.
Yeah.
Like again, using mirrors and things like that.
Interesting. So you think that's a more viable option than Mars, or
Not
it's
necessarily more viable. I think it's another option,
another option?
and it would be significantly harder to resupply if something would go wrong. So you'd have to be able to. It would take a long time to do it as well. I'm just saying it's probably our second best option for colonization after Mars.
Yeah.
It's just a lot of things to consider. Is how far away these things are. Like it's easy to say it's just the next planet over, but it's like the next planet over is a far fucking.
Yeah, I know.
It's really far.
That's why, honestly, one of the biggest things we need to do is work on our propulsion technology. We need faster, more efficient propulsion.
As soon as we get that nuclear going on.
Well, that's an option too.
Nuclear what? Nuclear powered rockets?
Just nuclear anything.
You just drop nukes out the back end of the ship and blow them up.
Wait, what?
It's one of the theoretical possibilities for both interplanetary and intergalactic travel, is because nuclear weapons produce a lot of energy really efficiently for how much mass is involved.
Okay.
So what you do is basically you throw a nuke out the. It's not exactly like this, but dumbing it down a little bit.
There's another cool idea. It's not really has to do with getting humans anywhere, but there's these like micro sails, like little bitty satellites, little bitty ships with a solar collecting sail, and you shoot lasers at it, and you just keep shooting a laser at it, and over time it builds up enough momentum just to like get cruising, and that's an idea to kind of send something out to different galaxies.
Mm-hmm.
Just keep beaming lasers at these sails until it collects enough momentum to.
And then they use the infrared from the whatever star they approach to slow down.
Mm-hmm.
On the opposite side of the sails.
So
yeah, there's all sorts of really neat
There's
ideas.
a lot of crazy propulsion ideas out there.
The coolest one is one that's actually, again, been explored in science fiction, and is theoretically possible. Is a kind of variation of the warp drive that actually doesn't involve time dilation.
Cuvier drive.
Yes, the Cuvier drive.
Yeah.
The only problem is we don't have the exotic material that we need. We need to find a material that we can use as reaction mass to get going.
I think, Danny, didn't you show this to me a couple years ago?
Probably.
Oh man, because the name sounds familiar. Cuvier drive. Okay.
It's Alcubierre, I think.
Alcubierre.
Yeah, that's right. Alcubierre.
Gosh, man. Well, I mean, there's so many possibilities, and I kind of want to get a little more deeper into the discussion on space, and I did want to touch on Space Force. I think right now it's in its infancy, and we don't really know what it's going to be, but I think it's only going to, benefit, our future, which I firmly believe is, space and colonization and controlling the skies. So, well, we're approaching another hour here, guys. So I'm gonna wrap it up. Trevor, thanks for coming on. Definitely.
Thanks for having me.
Yeah, definitely want you on some more episodes. I definitely want to do, since you're into games, I definitely want to do a gaming episode, specifically esports, because I'm kind of into that. So space is kind of more Danny's alley, but I definitely want to get some other interesting topics on, so we could probably plan for that at some point. But was there anything else you guys wanted to discuss before we sign out of here?
No, I'm good. Yeah.
All right. Well, thank you guys for coming on, and thank you guys so much for watching. And until next time, this has been another episode of Trivial Objections.